Hello dear students, I hope all of you are safe. It's time to nuclear chemistry. Lesson 1, atomic nucleus and elementary particles. In late 19th century, scientists discovered that there are very tiny negative charged particles in the atom called electrons. After many experiments, scientists Rutherford and Niels Bohr description the atomic model. Number 1, atomic model has a relatively heavy nucleus which carries positive charge. Number 2, the mass of atom is concentrated in its nucleus. Number 3, negatively charged electrons rotate around positively charged nucleus in certain orbit called electron levels. Number 4, every energy level has a certain number of electrons which can't increase. Now, in 1932, Rutherford discovered that the nucleus contains positively charged particles called protons. The mass of protons is 1,800 times greater than that of electrons. In the same years, Chadwick discovered that the nucleus contains although neutral particles called neutrons. Mass and atomic numbers. Atomic numbers, it's the number of positive protons in the nucleus which equals the number of negative charged or negative electrons revolving around it. Number 2, mass number, the number of neutrons and protons. Number 3, the number of neutrons equal mass number minus atomic number. Number 4, protons and neutrons inside nucleus are called nucleons. Atom is neutral because the number of positive protons inside nucleus equal the number of electrons revolve around the nucleus. Isotope atoms of the same element which have the same number of protons but different number of neutrons. Isotopes atoms are similar in electronic configuration, the number of electrons and chemical reactions. Hydrogen isotopes, nucleus of hydrogen has one proton. The nucleus of hydrogen isotope which has a proton and neutron is called deuterium. The nucleus of hydrogen isotope which has one proton and two neutrons, it's called tritium. That's it. Hydrogen, one proton. Hydrogen, deuterium, one proton, one neutron. Tritium, one proton, two neutrons. Energy and mass equivalence. Scientist Albert Einstein discovered that energy can transform to energy and vice versa. One can calculate the amount of energy produced from transformation of matter by using the following law. Scientists use a unit to measure the mass of atoms. This atom is called atomic unit. So, E equal mc square. E equal the amount of energy in joules. M equal mass of matter being transformed to energy in kilogram. C equal speed of light. 3 times 10 power negative 8. 3 times 10, power 8 meter per second. When matter of mass 1 unit transforms into energy, as what happens in nuclear reactions, we can calculate the amount of resulted energy by using Einstein's law. As the following. E equal m times c square. Or E equal m times 931. Nuclear force and nuclear binding energy. There is a force binding nucleons, protons and neutrons together inside nucleus. This force is known as strong nuclear force. Strong nuclear force. Properties of strong nuclear force: it's short range force. Number one, it's a short range force as it doesn't bind to nucleus together unless the distance between them is less than 10 to 15. Number two, it doesn't depend on the type of nucleons, and it one of the following pairs: nucleons, or neutrons, protons. When nucleons bind together forming nucleus, they lose their potential energy, which gives them negative potential energy. The same happens when electrons enter their energy levels. Nuclear force bind positive protons together, making them overcome the repulsion force between them. The importance of negative nuclear potential energy: it's responsible for stability of nucleus. Number one, it's responsible for stability of nucleus. Number two, it holds the components of nucleus together. Number three, it overcomes the repulsion force between protons. The difference between the potential energy of a free nucleons and that of nucleons inside nucleus is called nuclear binding energy. What is the source of nuclear binding energy? The mass of cohesive nucleus is less than the summation of masses of its nucleons, because this difference is mass defect transforms into nuclear binding energy. M equal ZMB plus NMN minus MX. M equal mass defect, Z equal number of protons, N equal number of neutrons, MB equal mass of protons equal 1.007825, Mn equal mass of neutrons equal 1.008665 unit, Mx equal actual mass of nucleus. A part of mass of each nucleon inside nucleus transforms into energy, which is known as nuclear binding energy per nucleon. Nuclear binding energy per nucleon equal BE over A. BE over A. BE equal ZMB plus NMN minus MX times 931 by million electron volt. BE equal delta M times 931 by million electron volt. Example number 1. Calculate the nucleus binding energy per nucleon in Ca24 if Ca24 equal 40.078 unit, Mb equal 1.007825 unit, Mn equal 1.008665. Solution: BE equal ZMB plus NMN, it's equal theoretical mass, minus MX, it's equal actual mass. This bracket equal delta M times 931. ZMB, the number of protons 20 times mass of one proton plus number of neutrons times mass of one neutron, minus mx actual mass times 931 equal 234.4 MeV. Nuclear binding energy per nucleon equal Be over A. A equal atomic mass, 234.4 over 40 equal 5.86. Okay? Dear students, it's the end of the lesson. I hope you understand it. Bye.